About what we call the non-parametric tests. Okay, I think from morning you are very much busy with understanding what you mean by parametric, and now I'm going to mean what you mean by non-parametric. Of course, there is a quite a difference in what you mean by parametric and non-parametric. Okay, if you go to the dictionary meaning, parametric means there is a parameter, and non-parametric means where there is no parameter. Many people make fun of this. Actually, I should not call it as a buzzword, but of course, this is an inherent word we use. Okay, parametric and non-parametric. So, what is the difference between a parametric and non-parametric? So many people will say, looking into the dictionary, they say whatever I have said right now, but to understand in the conceptual way, okay, in more intuitive way, and also with a more rigorous, okay, to understand the concept of parametric and non-parametric means, let us start with the introduction, okay. So let us go to the introduction. You see, there are many of the tests in a traditional. In a traditional way, there are many tests which are developed by making certain assumption about a parameters. Now, in yesterday's session, when I started with one of the thing, okay, let me share that also because I have to connect that with this. Okay. So, with your due permission, I'm going to share whatever I have talked yesterday, and I will be connecting that one to the today. Now, coming to this part, come to this exponential distribution. I told lambda is a parameter. When you come to binomial, I told p is a parameter, where n is a number of trials. Okay. When you come to geometric distribution, there is a only p is there, q will be you are going to obtain with a certain. Now coming to this exponential, uniform is one of the very rare case because that enjoys lot of properties in a statistical inference. Whenever we are going to study, this uniform is a guy who is a odd one. Okay, we are not bothered much about that one. Coming to exponential, this theta is a parameter here. But when we come to the celebrated distribution normal, which we discussed yesterday, so here mu and sigma will constitute the parameters for this distribution. Mu and sigma will be the parameter. In exponential case, we have only one parameter, whereas in the case of normal, we have two parameters. So when we started with whatever the things in yesterday, I stopped in the last slide, the functions available, because I used D, P, Q, and R. I have taken only the example for binomial, but I illustrated with a normal also. So the parameter, whatever is there for each and every distribution, now we are going to understand those conceptual way. Okay. Yeah. Now coming to my slide for today's session, there are many tests. What happens is whenever we are going to talk about the data, what is a data? Data means, see, most of our statistical techniques or statistical methods which are developed, they all are based on a sample. Sample is a portion which you have taken from a population. Now we have to understand what do you mean by a population and what is a sample. The mathematical model, whatever we have discussed in yesterday evening, okay, that all refers to the population. Now we are taking a portion of it and we are going to study whatever the characteristics that we have got in a sample, and that we are going to infer to the population. This is what we are going to do in statistical analysis. Okay. Most of the time, what happens is whatever the distribution and whatever the underlying thing, whatever is there, most of the times, yes, the sample which we are going to draw, always we say that it is a random sample. But when we draw, is it really going to be a random? There is a one question mark. Second thing is, whatever the sample we have taken and whatever the inference we are going to draw, does it going to convey or does it going to apply to the whole population? This is one of the two things that one has to understand. Say, for example, now in Karnataka, I don't know how many of you are interested in politics. Okay, in this another 3 4 months, we are going to have a election. So there will be exit poll. Many people will say, yes, before there is a result, there are many news channels. Say, for example, Republic TV. There is Arnab Swami, I don't know. He is there, and there are many people like that. So, with that exit poll, they are going to say that today BJP is going to win. Tomorrow there is a Congress is going to win, and day after tomorrow there will be a some allied forces. Allied forces means the local parties within the state. They are going to infer how they do that one. So they are going to take a sample out of it, and then they are going to make that one. In fact, whenever we come to this election poll, we call that as a paradox. Okay. I'm not going to touch that paradox right now. Okay. Now coming to this one, in that whole population, if I wanted to study the each and every unit, that will become a census. But what we do in statistics is we are going to take a small portion of the population, which we call it as a sample. How to choose that small population is going to be the sample, which is a random thing. In most of the situation, what happens is many people will think about this normal distribution is one of the assumption. Of course, yesterday I have plotted two graphs in a two lines in a single graph. Okay, normal with mean 0 and normal with 1, having a location parameter 0 and 1. I have plotted both the graph and I have shown you that one. See, what happens here is in parametric sense, of course, yesterday I have used a word called normality is a celebrated one. Again, normality is a myth. It was highly abused and it was highly appreciated. In both the sense, normality is enjoyed in a many real life situation. Okay. Now, what happens if normality is not there? Then we have to see. Okay. Yeah. So this is about the introduction. So many of the tests in traditional are based on samples that follow certain assumptions. We call that as a parameter. Of course, there are randomly drawn from normally distributed. Again, this is one of the word which we don't accept in non-parametric sense, but we take into the consideration. Okay, consists of independent observation, of course, except for paired values. Paired values I'm going to talk in another 2 3 slides. Okay, have respect respective populations of approximately equal variance. Yes, this is one of the condition, and there are other things. Okay, so now what happens is we have to come out from whatever the traditional things are there, and now we are going to have a barely assumption. Okay, what happens here is just a minute. Okay, now coming to this one, to overcome or to relax these assumptions, whatever we have assumed, normality and all other things, Okay, in a parametric sense, what we usually do is whenever we take a sample x1, x2, xn, we assume which follows f, theta of x. So what happens is in a traditional parametric sense, this f is going to be assumed. In most of the sense, what we do is this f is assumed to be normal, or it can be any other specified distribution. But in the case of non-parametric sense, we don't assume what is this underlying distribution. Okay, to overcome all this relaxation and all other assumptions. Okay, this x1, x2, xn is a random sample of size n drawn from a population having the underlying distribution f. We don't assume this f to be a specified one, like in particular binomial, exponential, hypergeometric, normal, whatever. We are not bothered whatever that f is there. But we are going to assume some mere assumptions. Okay, this is mere means very few assumptions as compared to the parametric sense. Okay, this theta is a scalar or a vector, whatever is there. This theta is a parameter for us. Now coming to this f, here f is assumed to be the first thing in non-parametric. What we do is most of the traditional non-parametric methods. Okay, whatever I'm going to discuss in this session is going to assume f to be a continuous. You can ask me what happens if f to be a discrete. That also I'm going to address. That also I'm going to give an idea at the end of this session. Okay. So f is assumed to be a continuous. Sometimes with an additional assumption, we assume f to be symmetric. There was a question. Okay. One of participant asked to Suresh sir. Okay, means in the previous session I was just attending that one. They asked about symmetric. Uh, can they put that comment again in the chat box? Who asked about symmetric?
I think it was Vaishnavi,
Yeah,
regarding the simplicity. Yes.
yeah, yeah.
Yes,
She's
she
there.
is there. Vaishnavi, can you speak up? Vaishnavi?
Yes, ma'am, I'm
Yeah,
putting
okay,
that
okay.
comment again.
Okay. Yeah, yeah, yeah. Please see. You are always welcome. You interrupt me in any time. Okay, I'll be there to answer that question. Yeah. Though the data set shows skewness, yes, very good comment. Yesterday, I have plotted two graphs for binomial point 0.3, point 0.5, and point 0.7. Point 0.7 I didn't address. Point 0.7 and point 0.3, it is going to be right skewed and left skewed. Okay. Point 0.3 is right skewed and point 0.7 is going to be left skewed. But when you take p is equal to point 0.5, it is going to be a symmetric. This is what I s- made a stress yesterday. Even with the normal distribution also, I made that one. Yes, this is one of the very good comment which I like. Okay, I'm going to talk about that why we need that symmetry, because what happens is in the case of parametric we assume lot of things. Okay, this x1 x2 is a random sample means IID. Always we are going to talk IID. Then we are going to take this theta to be having sufficient, minimal sufficient, this, that, everything. But when you come to the non-parametric sense, we don't assume this f to be any underlying distribution. Instead of it, we assume very mere assumption, continuous and symmetric. Symmetric about which point? Symmetric about theta. Yesterday when I plotted both the normal curves, one was symmetric about 0, another was symmetric about 1. Symmetry means we have to talk about the point at which it is going to be there. Yesterday that binomial 0.5 was there with n is equal to 10. About 5 it is going to be symmetric. Okay. Hence, non-parametric methods play a major role in inferential statistics. Now coming to what I mean by inferential statistics. There are many areas where statistics is highly used. Okay, one such area is the clinical trials. Whatever the new drug. So many of you have taken Covishield, Covaxin, or whatever the Sputnik. There are many nowadays you can see for the corona. And sorry to tell you, I have never taken any vaccine till today because yes, I'm hard you forget about those things. Okay, now a new drug is launched or a new drug is going to be brought into the market. We have to see the consequence. What happens is many a times don't say anyone that I have not taken a vaccine. I have taken a vaccine, but it is not actually a vaccine. It is called as a placebo. What happens is when a new drug has to be launched to the market, then what happens is what the company, the manufacturing company, what they will do is they manufacture the treatment. Okay, then they cannot able to apply on the humans. This is one of the very bad thing. So for any vaccine to come out highly before this, before COVID, before this pandemic situation, if you observe the last drug which was brought into there, okay, the plague and all before that, it has taken minimum 15 years, minimum 15 years to undergo the trials. But this Covaxin has been whatever for a COVID, whatever the things are there, it has come in 2 or 3, minimum about 18 months. They have taken that much. But how they have done? They have not applied on the humans. They have done very fast, and they have seen the consequence also, whatever is there. Okay. So now what happens is this non-parametric whatever methods are there, they are highly influential in this inferential statistics. Means whenever we wanted to see the effect of some medicine or effect of certain things before applying and after applying, means post and pre. Post means after applying, pre means before that. Now we wanted to see how the effectiveness is there. So to study this one, the very famous test, there are some tests which are available. The very popular tests are site test, that is test for location, that I'm going to talk. Okay. This Wilcoxon side rank test is one of the celebrated one, where Frank Wilcoxon, his name itself, Wilcoxon means he's a scientist. Okay, he's a biologist. He's the first person who has developed this test using side drag. I will tell you what you mean by side drag. In 1948, he has developed this one, Frank Wilcoxon. Okay, and then later on it has been updated as Mann-Whitney-Wilcoxon test, but just I am naming it as a Mann-Whitney test. Then comes the run test. Kruskal test I will see. If possible, I will cover this one. But this Kolmogorov-Smirnov test, I will talk about the goodness of it. Yesterday I told about goodness of it test. Now let me start with sign test. Okay. Yeah. So let me go through the first test. Okay. Sign test. So what happens in the case of traditional parametric test? In the case of parametric test, what we usually do is we consider the magnitude of the observations. Suppose, see, if I consider this x1, x2, xn is a random sample, and then if I write small x1, small x2, small xn, which are the realizations. Realizations means yesterday I told how the random variables are defined. Now for each of this x1, x2, xn is going to be a random. and then for each of that I am going to make some observation, that is small x1, small x2, small xn. If I take a realization for all these observations, okay, then sometimes what happens is we are going to consider the magnitude. This is what I was giving an example for my students. Suppose if I am a principal or I am a head of the institution, what happens is for me is, what is the result in the college? Are all of the students are getting first class? No, there will be some students who are failure. There are some, but overall, head of the institution matter. What is the average percentage in that institution? Suppose the average percentage of that institution is going to be 75, then the head of the institution will be very happy. Why? Because is 70 plus 75 plus they are going to get a distinction. Means what he will claim, all the students in my institution are getting distinction. But there are some few students, maybe a 5%. Suppose in an institution there are 700 students. Out of that, there are 5 students who have scored 0. Then out of 700 I am talking, there are some 5 students who have scored 0. But still the head of the institution is saying that yes, all the students in the institution are getting distinction. He don't know what is the consequence, because if all those students who have got 0, 5 students who have got 0 out of 700, if they have got 75, then the overall percentage definitely it is going to increase. That is called the difference. That is called the distance. We are sitting at one value and we are looking at the differences. Of course, that 0 is also going to matter, while the whole, the average percentage in that institution is going to be 75. How that matter? Let us see. Okay. So what happens here is, suppose, as I told you, if I say 75%, whatever individually if I take that 0, whatever is there, that is also going to matter to that mean whenever we compute the average. But if I sit at a positional value, that is a median, what we call, whenever you take a symmetric distribution, whatever the question asked with one of the participant, I really like that one. If you take any symmetric distribution, always the measure of center tendency, whatever we call, mean, median, mode, all the three things are going to coincide. This is what the capturing is going to happen in non-parametric size. Means we are going to assume very mere assumption, and one assumption which we are going to use is this symmetry. Okay. Now coming to this sign test, what we do is we don't bother whatever the things are there, whether the student has got 0 or whether the student has got 100. Instead of it, we say 75 is a percentage. Now what we shall do is, the students who have got less than 75, we shall assign them with the negative values. The student who have got a more than 75, we are going to assign them as a plus. So here what happens is, in the case of sign test, this is what the things are happening in one sample. Suppose x1, x2, x3, xn be a random sample from f theta. I don't know what is this f. Now the hypothesis of interest is h naught will be theta equal to theta naught. This theta naught is called as an hypothetical value. this theta naught has to be given by the researcher. Please make note of this one. This theta naught, don't ask me if I take theta naught equal to 8, don't ask me why I took 8. It is a person who is conducting an experiment who has a pre-knowledge and they are going to set this theta naught. Theta is a parameter which is unknown. Now theta is equal to theta naught. Theta naught is a specified value. Now we can take any suitable alternative, not equal to, less than, greater than. So here, for the illustration purpose, I am considering not equal to. Now what happens is under H naught, if you see probability of x greater than theta naught and x less than theta naught, this probability is going to be half. Means what happens is, in the case of sign test, I am not bothering what is the magnitude. Instead of it, I will sit at theta naught. Theta naught will be some hypothetical value. Some hypothetical value I am sitting, and I will see how the other observations are deviating from this. I am not bothered about a magnitude. Just I am counting the signs. Okay, that's why whether the observation, whatever the observation I'm going to get, whether it's going to be less, that is going to be half. If it is going to be more, again that is going to be half. Means totally this comes to whatever yesterday I was talking about, a coin tossing experiment. Means Bernoulli trial, like that. So what happens is, here totally we are considering median. As I told you, whenever you sit at binomial with p is equal to 0.5, whatever might be the number of trials, so you are going to have a symmetric distribution. Then the sorry, then the test statistic to test the Hebron null hypothesis at alpha. Alpha is a level of significance, okay, which we have to set. Whether we have to go with the 5%, 1%, this is an unavoidable thing. The error, whatever is there, that we have to choose. What happens is, in the case of clinical trial, if I wanted to develop a drug for a cancer, if I take 5% of rejection, 5% means the level of significance, means the error, means the null hypothesis which is really true, I'm going to reject it. That matter a lot. Okay, so this is how, for a 1% or a 5%, this is going to matter when you go to the clinical trials. Okay, that further reading I will be telling you all. Okay, now coming to this one, at alpha level of significance, now what we shall do is, we shall call the test statistic as S is equal to summation I. This is an indicator function. Indicator function means whatever is there inside the bracket, if this thing will happen, we are going to put a value 1. If this is not happening, then we are going to assign 0. Means what happens here is, we are going to see the number of observations x1, x2, xn. Out of this n observations, we are going to see how many observations are exceeding the hypothetical value. That much count we are going to consider. So you can look into the literature. Indicator function plays a major role in the case of non-parametrics. Very simple function, but it's one of the greatest thing. Okay. So this is an indicator function. Now, so what happens in the case of inferential statistics, like testing of hypothesis? First is, we have a sample. We have to formulate the hypothesis, null and alternative. The procedure is like this: we have a sample, we have to formulate the hypothesis, null and alternative. How we have to formulate the null hypothesis? There are many management and other streams. I don't want to talk any other streams. What happens is, many people are very happy whenever we reject the null hypothesis. Okay, many. Many people are very much happy whenever we reject the null hypothesis, but they don't know how to formulate the null and alternative. Okay. So what happens here is whenever we formulate the null hypothesis, we have to make use of what we call the unbiasedness. There should not be any bias whenever we are formulating the null hypothesis. And its complement we have to consider to the alternative. So always we have to formulate the null hypothesis so that there should not be any bias enter into that thing. Whenever we are rejecting that null hypothesis means we are having enough evidence to support to the alternative, but we don't have enough support to that null hypothesis. This is one of the last question where sir has answered. Okay, last session I was attending that one. Okay, make sure always whenever we are formulating the null hypothesis, there should not be any bias. Whatever the complement of it, that will be the alternative. Okay, so here what happens here is the test statistic is yes, which is going to be, we are just counting how many observations which are more than the hypothetical value, and then we reject. This is called the rule to test this null hypothesis. We reject the null hypothesis if it is, if s is less than c1 or s is greater than c2, where c1 and c2 are obtained with the condition using alpha. Sometimes alpha is taken as a size also. That's the level of significance means how much type 1 error we are going to commit up to that level. But size is also we are having a freedom to go to up to that level. Okay. So whenever we are coming to all these things, what happens in the case of parametric test means, okay, please remember this one. We make use of one very technical word that is called distribution free. What happens is in the case of any other parametric test, we are going to consider the magnitude of the observation. Here we are not considering what is the magnitude. Instead of it, we are just considering the signs. That's why it is more flexible. Okay. So under the null hypothesis, this S follows binomial with n comma 0.5. Okay. So once you know all these things, then we can obtain the critical value C1 and C2, and then we can go with the rejection part. That I am going to illustrate in a very few minutes. Okay. Yeah. Now coming to this is a one sample test which we were talking. Now coming to two sample test, this was one of the celebrated one because this goes parallel to whatever we are having a pair t test before and after, means pre and post. Okay, suppose a tablet is developed for a BP patient. Okay, before taking a tablet, the person was having a high BP, and after taking a tablet, he might be having a normal one. Then the effectiveness of a drug is going to be talked about. So what happened here is together means this x1, y1, x2, y2, and xn, yn. So both these measurements are taken on a single unit. That's why it is called as a bivariate. Okay, bivariate means say univariate, bivariate, and multivariate. There are many words. Technically, we are going to talk. Suppose if I take height and weight of a same person, that constitute a bivariate data. But if I take a height of one person, weight of another person, that is not going to be a bivariate data. Height and weight of a same person means same unit. If I take a measurement, if I take two measurement on same unit, that constitute the bivariate. That is pre and post. So once if I have such kind of a data, x1, y1, x2, y2, then what we usually do is we are going to test whether both of them have a same distribution with the same location. Okay, so here I'm not using any same location word. Anyway, in the coming slide I'm going to talk about this one. So once if you understand what I mean by univariate, then bivariate will be very easy because we have a paired observations. So what you do is you define a quantity zi which is equal to yi minus xi, means each y1 minus x1, y2 minus x2, so on, yn minus xn. You define with the new quantity z1, z2, zn. Okay, then putting all together this z1, z2, zn, this will constitute a single sample. Means whatever is there, the sign test with the paired sample, we can brought into the one sample case. However, now you can ask me if there is no pair kind of thing. Yes, I have an answer in the next slide. Okay. So what happens here is this two sample case we can brought into this one. Now an analog to this one, okay, whatever we have understood regarding the side test, this test and Wilcoxon side rank test has been developed by looking into what we call the traditional t-test, pair t-test. Many of you have seen, look at this. Just I will be sharing with you. Look at this S. What S will take account? S will just take account the sign of the observations. It is not considering whether minus 3, minus 10. Minus 3, minus 10, it will take it as a minus only. Plus 3, plus 10, it will take plus only. It doesn't matter whether it is 3 or 10. Only it take account of plus or minus. Whereas this paired t-test is there, no? What it does is it will take x bar. X bar is the sample mean. Whenever you compute the sample mean, as I told you, even whenever you take account of minus 3, minus 10, many people will say that that is nothing but minus 13. But 3 minus 10, that will give us minus 7. Because that magnitude is mattering a lot. But whereas if I have 3 and minus 10, I have plus 1, minus 1. That will be 0. This is an advantage of sign test and a drawback of sign test. Okay, it just take account of the signs. Okay, whereas the traditional student t-test, whichever is developed, it take account of the magnitude. That's why this has an advantage. Only this test, whatever I have written here, t is equal to x bar, this test is going to be validated only if the sample x1, x2, xn, whatever we have considered here, if it follows normal distribution. That's why we call normality is a normal distribution is celebrated one. Also, the assumption of normality is a myth. Okay, so this is one of the tests. Now looking into this sign, see there is a plus 3 and there is a minus 10. If I take into account of the magnitude, then I'm going to get minus 7. Whereas if I simply take the sign, there will be plus 1. I'm going to assign to 3 and minus 1 for a minus 10. But if I add 1 and minus 1, that is going to give 0. But there is a difference of 7. Isn't it? Yes or no? Yes or no? Hello? Hello? Hello?
Yes, sir. Yes, sir.
Is it minus 7 or how much? How far I'm sitting at 3 and minus 10. So how far I am from 3 to minus 10?
13 distance.
13. 13 or 14?
I think 14. Zero
Okay.
is also included.
So 0 is a 0. Okay, you have to include that 0 also. Okay. That is called zero deficiency.
Yes, sir.
Yes. Please always take into that consideration. Okay, don't have any deficiency. Now 3 and minus 10. Okay, we are at a right hand side and we have to go to the left hand side, provided I am setting it in front of the real line. Okay. Yes, good. Now coming to this one, only in the case of sign test it will take the signs. Now coming to this one, Wilcoxon sign rank test. This is again one of the tests which I was talking about. The Frank Wilcoxon has developed this test for the first time. Again, he has developed the test for a paired t test. Okay, whatever I was talking, the sign test and other thing. So instead of considering the signs, he has taken a ranks. That's why it is called as a signed rank. Signed rank means what he did. He took a paired sample x1 and y1, x2 y2, and so on xn yn. Then he tried to see the both are having a same distribution or not. Then again he defined the difference. Okay, he has come down to 1. Then what he did is he took this zi. In the case of sign test, we have taken just the sign. If it is negative, we are going to assign -1. If it is positive, we are going to assign 1 or 0. 1 0 1 0, like that they have assigned whatever the indicator function was there. So instead of it, what he tried to do is we shall just arrange the whole observation irrespective of sign by taking the absolute value. Forget about 3 and minus 10. Simply you order them with the absolute value. Now what happens is this plus 3 will come to the left side, whereas the modulus of 10 means that will become a 10, that will come to the right hand side. That will have a more rank. Okay, if you arrange the observations in a ascending order, if you take the absolute values, then this 3 will have a rank of, I don't know, whatever the observations are there. Just I am taking for illustration, there will be 2 observation out of some 100 or 10 or 30, whatever is there. Just I am considering 3 and minus 10. If I arrange them with the absolute value, then I have a 3 which will have a lesser rank, and this minus 10 is going to have a more rank. Then what happens is, so what he has suggested is you take this yi xi, whatever the difference is there, then arrange them with the absolute values, and then for each of this, whatever the arrangement you are making ascending order with the absolute value, you assign a rank, and then you take account of the ranks. W plus means you take all positive observations ranks, you take its sum, you take all original negative observations. I'm not talking about the absolute value, the original negative observation. You take its ranks, you take their separate sum. Sum of all the original observations which are positive having a ranks, then all negative observations having the ranks, their sum. You add them, you call that as a W plus, W minus, and then you define a new statistic, that is W is equal to minimum of W minus W plus. You take all these things, and then once you compute this test statistic, whatever is the W, okay, upon getting this one, you define a test statistic rule. Again, so for this, whenever we are talking about the computation of a distribution of a statistic, distribution of a test statistic. I'm not talking about a statistic, a test statistic. Always, whenever we wanted to take a rejection rule, if you observe here, under the null hypothesis, I know that this yes follows binomial. I will reject if my test statistic is less than C1, greater than C2. This is called the critical values, okay, which are obtained with the size condition alpha. Another is p-value. Many people are using this p-value, okay. If the p-value is less than or equal to that alpha, alpha is a criteria that you are going to consider, whether it's going to be 5%, 1%, or some people they consider it as a 10% also. So looking into that p-value, they are going to make a decision, okay. That p-value is nothing but that alpha, whatever the level of significance means, you are rejecting the true hypothesis. I know the sample has come from the same population, but still I am rejecting. That means I am committing a error. That is called the type 1 error. Okay. The type 1 error, type 2 error, that you can understand later on. Okay. Yeah. So for this again, this Wilcoxon has given a table value for all this W that you can see, or else you can compute the p value. Now look at this. In this both the cases, I have considered the paired test, paired sample. X1, Y1, X2, Y2 means whatever X sample and whatever Y sample, I am going to have a same size. That is a n. Suppose if the sample sizes are different, I have x1, x2, xm is one group, and y1, y2, ym, yn is another group. Means I have two groups. Now I wanted to compare these two groups, means the distribution of these two groups. Then what happens is the generalization of this Wilcoxon sign rank test, instead of taking a paired sample, we are going to have a two sample case. That is, let x1, x2, xm be a random sample from F and y1, y2, yn. If you look into the suffix of this m and n, both the samples have a different size. Size means here there are m observations and here there are n observations. So to compare this one, this is a generalization of whatever we have understood regarding a Wilcoxon sign rank test. Then what this Mann and Whitney have suggested is you put both the X observation, Y observation together, irrespective whether it is going to be X or Y. Okay, you arrange them in a ascending order. So ascending order, you arrange them. Then you see the first observation whether it's going to be from X or Y. Similarly, the second observation is going to be from X or Y. Like that, you see how many Y's are there in that thoroughly mixed up situation. Okay? Then you put a rank. Suppose I have a three observations. Let me tell you very clearly. Okay, I have a three observation, 3, 8, 11. 3 is from X, 8 is from Y, 11 is from X. Means I have two observation, M is equal to 2, N is equal to 1. I have M is equal to 2, N is equal to 1. M means I have 3 and 11. I have a two observation from X, that is 3 and 11. I have N is equal to 1, only one observation, that is 8. Then if I mix up all the three and if I arrange them in a order, then I'm going to get 3, 8, 1. What I will do is I will assign first rank to the 3 in ascending order. 8, I will be assigning the rank is equal to 2. and 11 is going to be 3. Now, what is the rank of the Y observations? There is only one observation, that is 8, which is holding a rank of 2. So, in this case, only I am taking the sum of the ranks of Y's. Okay, thoroughly I am mixing up X and Y. I am arranging them in ascending order. I am putting a rank for all these observations, whatever the combined is there. Then only I am collecting the ranks of Y and I am taking the sum. So this is what the Man-Whitney test is going to talk about. Again, for a larger value of t, we are going to reject the null hypothesis. Okay. The null hypothesis again it's going to be 2 sample. So these are the tests. Okay. Whenever you see t-test with a 1 sample, 2 sample, and pair t-test, there are 3 applications which you can see. Analogous to that one is sign test, Wilcoxon sign rank test, and Man-Whitney test. Okay. In the case of parametric test, only we talk about the mean, but whereas in the case of non-parametric test, due to the assumption of symmetry, okay, whatever I told here, due to the assumption of symmetry, mean, median, mode, all the 3 things will coincide. Hence, we are only bothering about the median. Okay. So the best one is this peanut data. I have that data set. Okay, quickly I will share that one in a chat box. I think all of you can use that one, and we can run a program for it. Just let me share that one. Okay, I don't know where I have to add the data. So shall I send to madam? Madam, hello, Savitri madam. Hello. Yeah. Shilpa, yeah. So can you just help me how to share the data? Okay. Already I have a soft copy. Savitri madam is there.
Sir, I think she's not.
Yes, sir. I'm there. I'm there, sir.
Okay, madam.
Hello.
I'll be sharing the data to you. I'll be sending through.
Okay.
Okay,
Through email
can,
you are sending?
yeah, email. Just you can put it in the chat box. Okay, quickly.
Okay. Okay.
Yeah. So I have sent you that data, madam.
Okay, sir. I'll be just putting it in.
Yeah. Please do that.
So I have put it in the chat box.
Okay. Okay. So just you can go through these data sets. Okay, quickly. I'm going to analyze this data only. Okay. Now first let us look into this one. Okay. I'll be sharing my R console. So this is a peanut data which I have shared with all of you. You close the bracket here. Okay. So totally how many observations are there? Let us see. Okay. First we shall run this one with the control R. You can see this many observations are there. Okay. So this is a peanut data. Now we shall make use of the sign test and Wilcoxon sign test, whatever is there. Okay. Now, so for this data, what we shall do is we shall test whether how many observations are there here. So just you type length of, I don't know how many are there, length of peanuts. Okay, you have to make sure that the variable name with the case sensitive because these are case sensitive. So totally there are 16 observations. Now we shall test whether this entire whatever the data is there, is it going to have a on an average the hypothetical value is 8. That theta naught is going to be 8. Okay. Okay. Now we are going to test for the hypothetical value 8. Okay. So what's the average? You can just see. Okay. You can compute the mean. Okay. The mean means that AVG, whatever is there. AVG of whatever the periods is there. That's a simple average. Okay. Whatever the mean or mean. Whatever. Sometimes I might be wrong with that. So if you look into the sample average or sample mean, it is going to be 7.83. Whereas if you look into the overall, we are going to test to about 8. Okay, so how to test that one? Let us see that one. Okay, but variance we are going to assume that it is known. Okay, so for this, we shall type this command. Okay, there is a command called wilcox.test. Wilcox. Okay, WILCOX dot TEST. So whenever you are using any test, you have to prefix with whatever the test is there. WLCOCOX dot test. Then you pass whatever the data is there. So here the data is peanuts. PEANUTS. So since it's a case sensitive, I have used a first letter as a capital. So make note. If you are using only P, that is also fine. Okay. Now I have to specify what is a hypothetical value. If you don't specify the hypothetical value, it will take it as a 0 by default. So now let us test it to mu equal to 9. Sorry, 8. This 8, don't ask me how I took 8. That is by knowing the earlier thing. Okay. So now let us run this command. If you come to this one, Okay, we are going to get a output like this. Okay, all of you can see Wilcoxon sign rank test with continuity correction. Here, that continuity correction means there will be not any two observations which are tie or which are not having any other thing. Okay, only there is no ties. There are exact. So what happen here is the test statistic value means what happens here is it will subtract each of this observation 8.08, 7.12, 7.89. Each of this observation will be subtracted with 8. Then it will see how many six out of these 16 observations, how many are negative and how many are positive. Irrespective of whatever the things over there, it will arrange the data with the 16. It will consider only those ranks of observations which are exceeding 8. That is 1, 2, 3, 4. There are only 4 observations which are greater than 8. What it will does is it will take the whatever the difference is there, irrespective of whatever the magnitude, it will arrange it, and then only it will take the ranks. Upon subtracting, we are going to have 0.08. Then similarly the other 3, wherever it comes, in which position it comes, it will take their sum, and that will be added here. Similarly, the negative also taken, but minimum thing it will be considering. Okay. Then, as I told you, it will compute the p-value. Okay. So if you look into the p-value, it is going to be 0.026. Now you talk about what is alpha. If my alpha is equal to 0.05, 0.05, that means here the p-value is less than 0.05. Hence, we are rejecting the null hypothesis at 5% level of significance. If I consider 1%, 1%, that will be alpha will be equal to 0.01. Alpha will be equal to 0.01. Here, p value exceeds that 0.01. Here, we do not reject. Always remember that we we are not at all accepting. We never use the word called accept H naught. Only we are rejecting the H naught, but whenever a situation comes, we never use the word called we accept. Instead of it, we use another synonym that is called as a we do not reject. So at 1% we do not reject, whereas at 5% we reject. It happens. Yesterday I was talking about one graph, okay, where all of you might be knowing. Okay, just I will share with all of you for the better understanding. Okay. Now what happens is I know that my test statistic will follow some distribution like this. I'm only talking about a continuous thing. Now what happens is yesterday there was a question regarding a quantile. Now what happens is whatever the region whichever comes over here, I will consider this as a 0.5%. Now what happens here is my test statistic value, if you observe here, that is 24.5. Okay. Suppose my 24.5 will fall here. Then whatever the region which is greater than this value is there, okay, whichever I am marking, So this region is going to be 0.02. This is called the p-value. This entire region, whatever is there, this black color, okay, whatever you observe with all these things, okay, this is going to be 5%. Okay. Now look at 1%. See, this region is going to be 5% means where the 1% will come? The 1% will come here. So definitely, see, after 24.5, the region will be 0.02. Then definitely this will come more than this 24.5. Hence, at 1% we do not reject, but we are rejecting it 5% because this 24.5 will fall here in the rejection region in this 5% level of significance. But whereas for a 1% we are accepting. That means this entire whatever the remaining region is there. So this is called the acceptance region. So I can just fill whatever the things over there. Okay. Sorry. So whatever the things over there. Okay. So these are all will be acceptance region. Okay. So this is about the Wilcoxon sign rank test. Also, you can illustrate that one by using the whatever the remaining things are there. Now for the two sample test, just I will illustrate. Already we are running out of the time. Okay. Yeah. So now look at this one. So this is about a peanut data. Now we have a two sample, that is X and Y. Just quickly you can go through this one and you can enter the data and you can summarize them. Okay. So you can just type this data, whatever is there. Okay. You can copy paste this one. Here the sample sizes are different. Just we type this as a yes. Has come like other things are there. So now we have a two sample X and Y. Forget about this. This story is over. Now coming to this two sample, we have X and Y. Remember they are case sensitive. You can have a small x, small y also. If you are not using any caps, you can. But once you redefine, you have to run that one. Then only we will get the variable is going to be stored. Okay. So then quickly we can use Wilcox. Okay. If you have a two different sample, that's what the man-Whitney test will come into the picture. Wilcox dot test y comma x. If I run this one, then again I'm going to get the output. So here again W will be 59 and P value will be 0.002. Means here almost it is going to be after the decimal two places are having 0. So hence at 1% also it will reject. If the hypothesis is rejected at 1%, definitely it rejects at 5%. If the hypothesis is rejected 5%, you cannot assure at 1%. That is one of the things which we have seen. Okay. So this is about the uh, just I will take another 2-3 minutes to explain what we call the test for randomness. Okay, very quickly I will go through that one. Okay. Okay. Now coming to this test for randomness, there is one of the very beautiful thing is there. What happens here is whenever we go for test for randomness. Okay, actually I prepared the slide, but I am not getting that one. So whenever we are in a queue, means yesterday we have generated some observations, random observations. See, actually, whenever we are generating the random observations, we call them as a pseudo random numbers. All are aware of this or not? Yes or no? You can ask me the question in the comment box. You can ask me. So there is nothing is called as a random. Whatever the observation we are generating, it is called as a pseudo random number. Yes, there is a command. If the sample size is greater than 30, we can use non-parametric tests. Yes, for any sample size you can use. Even with a sample size of 5 also you can use. Why? Because this non-parametric test, it will not assume the underlying distribution. It is totally distribution free. Okay. So for further reading, since it's already we are getting late, yesterday many people have asked me about one of the good book. Just I'm sharing my screen. Okay, so all of you can just go through this one. There is a book by Gibbons and Chakraborty. This is a book, Non-Parametric Statistical Inference. Okay, so if you go to the second one, you will get the PDF. So in Google only you will get the entire book. So this book talk about all the non-parametric methods, whatever is there, whichever I was discussing. So the entire book is there, 672 page. Okay. Yes. This is one of the classical one. There are many other which are there, but this is one very good book which will talk about. So whatever I was discussing about a sign test, Wilcox's sign rank test, even it will go to the rank test. It will go to all the things. If you just go through the page number 168, 166 or 168, okay, it will talk about whatever the other things over there. But they are not using any R, but they are using other software. Okay. So you can just go to the index. Okay. One sample test, whatever is 168.
Sir, please suggest, sir, non-parametric inference using R, sir, book, any book, sir?
Sir, actually, so once you can if you understand the techniques, you can use any other book. There is another book that I can't share in this public domain, but I have my own personal copy. Yesterday, I have received 3-4 mails from participants. I will share, but I cannot share in this because this is already available in Google. That's why I am sharing with you. Okay. So if you want anything with the R, yes, I have a soft copy that I will be sharing only with the personal thing. Okay, because there is a copyright act is there. I can't do that. Okay, sorry for it.
Okay.
But this is one of the theoretical background which explain Regarding R, I will be sharing personally. Okay, because right now you know how to get the libgin and all those things. Okay, that I don't wanted to share in this public domain. Okay, personally I can share. I have a lot of material. Yes, sure. Okay, so
Queries
with this,
from the audience?
because already we are running out of the time. Okay.
So any queries from the audience? Okay.
Okay.
If not, then I would like to thank Dr. Raghunath for taking out time for both the sessions and enlightening the participants regarding the distributions as well as the non-parametric tests. And non-parametric tests are widely used in all the disciplines, of course. And with this, I would like to thank you, sir. Thank you so much. And we look forward to
Yes.
you for further more sessions also
Yeah.
in the coming workshop.
Yes. So I thank uh, Savitri madam and also the authorities of Triple IT Allahabad. Okay. And one more thing, this is my, you can take it as a advice or a suggestion, whatever is there. See, this software thing, whatever is there, unless otherwise, if we don't practice, we are not going to have a command over it. So we have to practice, we have to regularly, we have to see that one. And one thing is, R is a very widely used and almost it since it's a free package, many people have done lot of updates. If you go to Crane, CRAN, okay, if you go to the R website, you will get the manual for each and every package. There will be a explanation for it. No need to ask anyone. But only thing is, what happens here is, whatever your requirement is there, for that you can write your own codes. Okay, so this is what we have done in our research work and all those things. Though we have not learned this R as a traditional one, because during our research time it was in a very infant stage, okay, very small, okay, R, but now it is very big. So what we are doing is, we are writing our own codes. We are writing our own. We have not developed any package, but whatever our requirement is there, first we will write the algorithm. We write the codes. We will get the output. It depends how you are going to utilize the things. So technology is like that. So whatever your requirement is there to use that one regularly, you have to keep in touch and you have to make a practice. Okay. Not only in R, nowadays, maybe in the next session you are going to look into the Python. I don't know, after another 5 4 years, next 5 4 years, there might be another programming language. Okay, apart from Python. So like that, technology is improving a lot. We have to cope with the things. Okay. Yeah. So with this, whatever the suggestion or advice from my end, yes. So according to your need base, you go through the things. If you have any doubt or anything, please, I'm always welcome. I have shared my email ID yesterday also, and today also I'm going to share. Okay. So my email ID is this. Regarding whatever I have discussed yesterday and today, so you are most welcome. You can write to me, so I will respond to that. Okay. So once I prepare whatever the write up is there, I'll be sharing with the madam, and then she's going to share with to all of you.